Hi everyone, and welcome to the second episode of Hands-on ACP Dev, back to basics with web development. So in this second episode, we will continue building out our Node.js server. And since I've been talking for a minute, please let me know how the audio is in the chat. I know we had some issues last time, so I want to make sure that we're all dialed in this time. And I do have a quick follow-ups from last week from the first episode of the stream. So first of all, I want to thank you all for your specific feedback, not only because it was mostly positive, but because that specific feedback really helps me tailor the content to your needs. For example, I had one folk saying that he really enjoyed the server side of things and how I explained that you should move more more code to the server side and things like that. And that kind of got me thinking. And I thought of more reasons why you should really be focusing on the server and should put more code in there. Let me switch to the iPad scene. So I think that's roughly where we were at last time. So we started, building the server out, and we drew this fancy diagram, showing the basic client-server architecture, and a few more good reasons to move more code to the server are, first of all, that think about an operation where you have to do some kind of calculation for a value. Let's say you have to transform a value or change currencies or do any of that sort. If you do it on the server, you most likely have to do it just once, and then you can just store the value in the database or somewhere else, and then just read from the database instead of doing that operation over and over again. So if you were to do that same currency conversion, for example, on the client, that would happen on every client, like in everybody's browser, that calculation would happen. And second of all, like security is a big thing, right? So if the code isn't exposed to the client, if no one sees the code, they can't manipulate it, right? So if you ship a web app and you ship front-end code, you should really think about that this code is running on everybody's devices, like in everybody's browsers, like desktop PCs, smartphones, wherever, and they see that code or could see that code if they inspect it and really manipulate it and reverse engineer it for that matter, which is of course not ideal. So whenever you can move things to the server, you should really do that. And then it's also easier to distribute because client caching isn't a thing if you just put the code on the server, right? So think about shipping a new version of your web app, of your front end code, but then a client has something stored in their cache and that interferes with other backend versions or things like that. So if you just put it on the server, whenever someone does a new request, like whenever let me turn this pencil on. So whenever someone does that right here, they always get the latest version of the code, right? Because it just runs on the server and you just updated this piece right here, just the server. And this update mechanism can come quite handy if you really have to update your version. So it's easier to distribute and to update. So that was just a quick follow-up. That was just my racing head. Just a few thoughts when I got some feedback from last time. And I really do appreciate this kind of specific feedback, or any feedback for that matter. Of course, best if it's constructive. But yeah, so always make sure to let me know what you think. So I haven't got any notes on haven't received any notes on the audio. So I just assume it's fine since nobody complained this far. Okay, so let's continue with building out our Node.js server. So let's go back into the code, which is this piece right here. So I already started the web server that we started building last time. One sec. So we have a very basic Node.js app right here. So it's essentially just a index HTML. It's exposing the default route. We're using Express, of course. And then we have a package.json where we define two scripts, the start script and the def script. The def script is running in this watch mode. And we have two dependencies, Express, which is a runtime dependency, as well as a def dependency. And then as a pure def dependency is nodemon, which is just watching our file system while we develop, and it restarts the server. And talking about this restarting the server, so in the terminal down at the bottom, I used npm run dev to start the script, right, to run the def script. But then I can also say npm start to start the script. So why do I sometimes have the run, and why do I sometimes don't have it? And the reason here is that there are a few sort of built-in scripts to npm that work without the run command. They're sort of shortcuts, you could say. So npm start is one of those, and then there's npm test as well, and then there's npm pre-start and a few others. But all the other scripts, except those specific shortcuts, all the other scripts have to be used with npm run and then the respective command. So npm run def in that example. Okay, so let's check out this app. So it's just responding hello world. And if you remember last time, we just used curl. Let's do that here as well. So we can just do curl http localhost again. So we can just use curl to do the same exact request, right? Again, a client could be anything. It could be a browser, it could be a terminal, it could be really anything. It could be a smartphone, anything could be a client. Cool. So let's now continue building out our Node.js server. And what we want to do here is we want to build a backend for a little louder would be good. Okay, I can talk louder, but I maxed out the volume for this mic, so I just have to talk louder, or you just increase the volume on your side. I'll do my best. Okay, so what we want to do here is we want to build a backend for a fictitious web shop, a hands-on SAP Dev web shop, where you could, in theory, order things like merch and cups and t-shirts and whatever. But it's a fictitious web shop. We're not going to actually go live with this. This is just our example. Okay, so why don't we start with a simple list of products that we want to have for this web shop, right? So I'll just put this simple array here. Let me increase the size here a little bit. So I defined a new const, like a variable that can change. And maybe we get into const and let and var and things like that, because const, now our product is a const, like it can't change, but then you can still add items to the array. It means more like it has to be an array, like it will always be an array from this point on, right? So it's not like super const. It can change like within itself, but it can't all of a sudden be a string. Like that wouldn't work. Okay, but anyway, so the products, a simple array of objects, and each product has an ID, a name, price, currency. You get the idea. Okay, and we have 3 products. So let's now, instead of responding to our default route with hello world, let's respond with products. Okay, let's save that and let's go back to our browser and refresh, and there we go. Now we get the product data back. Okay, cool. But the default route is probably not a good place for this kind of data, as we might want to put something else as the sort of entry door default thing, right? So instead of using the default route here, I will say that at /products, that's where we get the products, okay? So let's refresh again. Oh, and now we get nothing, okay? It cannot get slash because we now don't have a default route, okay? So let's instead go to /products. There we go. And now we get our data back. Okay, cool. So that is the get operation, right? That is the read. But we obviously want to have a full CRUD capable backend, right? Create, read, update, delete. So we only got one piece out of 4. So let's continue with, what are we going to do next? Oh, we're going to actually continue with the read operation, but now we want users to be able to query just one product. So instead of getting a list of all the products, we want just one, okay? And for that, I will, let me actually paste some code over. You don't want to see me typing for minutes and minutes. Okay, so I'll just highlight the code that I just put in. So we define a new route as part of our Express app, and whenever a user does a GET request at /products/ and then there's a query parameter in here which is called ID, and this one's optional because it has the colon in front of it. Let me just read that one comment in the chat. Hi, I would like to know how I can change my content type to application JSON explicitly while calling CAP service from SCP/BTP event mesh. Okay, very specific question. I think you can, with OData before and CAP, you can query, you can add to the URL of the OData request, you can add type JSON, I think. I will have to do some research, but I think that's how it works. And that will probably give you JSON back with the respective content type header. Okay, but back to this application here. So we now have a /products/ ID route, but the ID is optional. And if we get this request, we deconstruct sort of the request parameter. So we get the request object. In there, there's parameters or params, and then we get the ID from that, store that in a new variable. And then we go into the product, into our array, and we find the one product where the product ID matches the ID from the request parameter. So we just find out one product that the client queried for. And then if we don't have a product, we want to send them an error code, right? Because if they're querying for something that doesn't exist, we'll have to send them an error. We will get into error codes in just a second, okay? And if that is the case, we just return, and then that's it. But if we do have a product, we just send the product back, right? So let's test that. So let's just grab this ID here. So I just grabbed the first one, and there we go. That works. So we now get that one product back. So, and let me just change the ID here. So instead of a 6 in the end, let's just do a 5. And now we get the error message, product, blah, 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 not found. Okay, so let's get into, well, let's talk about error codes, right? So if we can't find the product, we send a 404. So we set the response status to 404, and then we send this message. So error codes are sort of divided into categories, and all the ones starting with a 2, like 200, 201, and all that is, good. That worked. Thank you. If it's starting with a 3, it means somewhere else, like I'm redirecting you somewhere else, or the content has moved somewhere else, things like that. Those all start with a 3, so 300, all the 300s. And then 400, all the 400s mean there's something wrong with your request, like it's your fault, it's the client's fault. For example, 404 means you were looking for something that doesn't exist, you know. And then a 401, for example, is you're not authorized to do this kind of operation, right? That's all the 400s. There's something wrong with your request. And then there's the 500, which means, sorry, I messed up. I, being the server, I had an issue. I, failed. There's something wrong with me doing this operation, but it's me who's at fault. It's not you, right? That's all the 500s. So 404, there's something wrong with your request since you're asking for something that doesn't exist. Okay, so that is the second part of the read operation. That's querying for one specific parameter. Now let's continue with the create operation. Right, and as always, feel free to put all your questions in the chat. Really looking forward to your input. So let's create the create. All right, so I will paste some new code in here, and again I will highlight all the code that I pasted in. So now instead of doing a app.get this time, we're doing an app.post. So whenever a client sends a post request, right, and we can't test that with just simply using the browser like we did here, right? So whenever we put an address in the address bar here in the browser, we hit enter, that's sending a GET request to this URL, right? But for creating a product, we want to send a POST request. So we'll need some other means to test that. We'll get to that in just a second. So app.post, if someone posts to /products, we expect a request body, which should contain the product. And then we want to do some checks here to make sure if the product, the request body, is a valid product. And if we check that method out, it's basically just defining a set of allowed keys, like a product can have a name, price, and currency. And if those are all, or if there are no other keys than those, then we return all good. And if we find some other key, we will say 400, like invalid product. There's something wrong with your request, okay? And then if we if the product is valid, so if the method doesn't stop here, but if the program continues, we set the ID of the product to a new UUID. We'll get to that in just a second. And we push this new product into the products array, so into this array of products, right? So we push the body from the request into this array, which is a const, but you can still change it. We talked about it. And so we push, here. We push it in there. We set the response status to 201, which means content created, like all good. I did what I was supposed to do. And then we send back the product. So we just return what we got in the first place. Okay? But we return the whole product, not just the request body. So if someone only submitted, well, forget what I said. We just return the product, okay? So, cool. Let's save that. And as I said, we can't just simply test that with just using our browser, right? We'll have to construct a post request in some other way. So I'll create a new test directory, and I'll create a no post.shell script, and I do have a curl script prepared for that. So with this little script, we just say, we have a curl script, like a HTTP request using curl, using the post method. So instead of doing a get, what we did before, we now do a post. And this is the URL, and then there's the content type that we set to application JSON, because we send JSON along as the request body, and then we just put the request the JSON, you know, in the body here. There's a new name, stickers, hands on ICP dev. You know, the price is €3, whatever. Okay. So I can't just submit that because, well, actually, why not? Let's just run into this error because error messages are beautiful, right? So I will now say shell, and then in the test directory, there's the post thingy, okay? Oh, and we get some weird error messages, okay? So is valid product, is running into an issue, blah, 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 blah. Okay, this is not the error message that I hope for. It's a little cryptic, but you know, I obviously know what went wrong, and it is the fact that this UUID v4 thing just simply doesn't exist because we, you know, this thing isn't defined anywhere. So I know that we want to use a package called UUID v4, and I will import it. Usually I like to sort my imports alphabetically, but whatever, we'll just run with this. So there's a package called UUID, and it exposes a v4 thingy, which allows us to just create new UUIDs on the fly using the v4 version, whatever that means. I'm not sure. There's probably difference in the versions. So let's just go to npm.js.com/package/UUID. So this is the thing that we want to install. So it is for the creation of whatever format, protocol, norm UUIDs. And we can do that by running npm I, which is short for install UUID. Okay. So I think that worked. Let's check out the package.json. Yep, that worked. Okay, so we import this this new package. We import the v4 method, but we sort of rename it to UUID v4 because obviously v4 is also used in the OData context, so it makes sense to give it a new name to not confuse anybody. And if we save that, and we can now restart the server, npm run dev, go back to the top, and then run the shell thingy again. Oh, we still get an issue. Let's see, same error as before. Cannot convert null, undefined or null to object. Okay, let's see what's going on there. All right, so app, post products, request body is valid product. Why don't we just do a console log at this point here? So this obviously wasn't planned. So it's failing at line 65, which is here. So at 63, we should still see the product. All right, you know what? I think we will just skip over this part. I'm not exactly sure what's going on here currently. Oh, I know. So it looks like it doesn't get the request body properly because it, you know, I did the app post products. Here I did the console log product and it didn't even log a proper product, right? Like a proper JSON. And that is because in order to be able to get the request body, like the body from the request, we have to tell Express to use JSON. By default, Express isn't capable of reading JSON from a request body, so we have to explicitly tell it to do so. App use Express JSON right here. So let's do it again and run the shell thingy. There we go. Cool. So now we get the response back, which is the whole product, with this new ID, which was auto-generated on the fly using this package. So now we can go back here and query all the products, and we now see 4. Cool. We now see 4 products. Very cool. All right. So that was the create. We have the create and we have the read. Now we want to do the update, right? So for that, I will again copy some code over. And I know that the index.js is becoming quite messy and quite long, but we'll work on that later, okay? So let me highlight the code again that I pasted in. So what we did here next is the app put operation. So a put is basically an update, HTTP put request at /products, and then the optional ID again, right? In a similar fashion to the read one specific product, we construct the ID from the request, or we get the ID from the request, but now with a put, obviously. And then again, we find the product that someone wants to update from all the products. If it doesn't exist, we send a 404. If it does exist, we get the new product from the request body, the JSON, which we now can use since we told Express to do so. Then we check if the product is actually a valid product, as in there's no unexpected keys in that product. And then we overwrite all of the keys from the new product. All the keys from the old product we overwrite with the new product, right? So object keys just basically creates an array of all the keys from an object, which we can then loop over. So we loop over all the keys that are in this new product, like name, price, currency. We loop over all of those. And for each of those, we take the value and use it to overwrite the initial product. And then we send the product back, right? And I know this is a lot, and this is sort of pretty complex, and you have to think of a lot of things. And maybe at this point, it's a good time to explain why the hell are we doing this that way? Why are we building our server in such a raw way? Like, sending all the error codes manually, setting the error messages, handling all the routes, handling all the methods. Why do we do that? We do it just to practice, of course. There's a great framework out there that we will get to, and it's called the Cloud Application Programming Model, or CAP, which abstracts all of this magic away from you, which is a good thing because it's error prone, right? You could see how easy it was to mess up, just forgetting one simple line. And CAP abstracts all that away from you, so you have to only focus on the domain modeling itself, essentially. Like saying, I have products, product has a name, a price and a currency. That's essentially all you do. And then you get all of this that we do here manually, you get it for free, right? But we do it here just to practice, of course, because we want to know how Node.js works and how this sort of stuff works under the hood, right? So that's why it's a little complex, and I know it's a lot, but bear with me. We're just here to practice, okay? So this is the put request. Let's write that, and then let's go into the test again and create a new put.shell script, because again, we can't test that by just using the browser. Because we can essentially only do a get request when we simply put that URL on the address bar, but we want to do a put as we have it here, right? We set the content type in the request header again, and then we set the price to 25, okay? And let's quickly check out what kind of product this is. So it's the ID starting with D76. So it's the cardboard cutout from Josh Bentley, okay? And its current price is 20 euros, okay? So let's write that, and then let's execute the test/put thing. And we now get the product back with the cardboard cutout from Josh Bentley, and now the price is 25 euros. Okay, so let's refresh it, and we see the updated price. Nice. So I think what was pretty cool about that was that we were able to send a post request just with this one key value pair here. So we only updated the price. And because of the way we built our put thingy here, where is it? So the way we built this here basically allows for only overriding the keys that we send as part of the new product, and all the other keys that we don't touch, they will just stay as is. So in this case, the loop that we ran here was only running. It was just one thing that we executed because we only had the updated price. So it was only the price of the new product overriding the price of the old product, right? Instead of having to send the whole product, like with a name and with a currency and price, we only updated the price, which is pretty nice, I think. Again, works, any other backend framework does that kind of thing out of the box, but if you build it from scratch, you have to think about these kind of things, right? So we can't just simply overwrite the new product with the old product because we would lose key value pairs, maybe. Okay, so that was the update. Very nice. So the only thing that's missing now is the delete. Okay, so let's create the delete. So now for the app.delete method, so when the server receives a delete request, again to the product ID, because if you want to delete something, you have to say what exactly is it that you want to delete. Again, we get the request parameters, and then we grab the ID from that, and then we find the product. More specifically, we find the index of the product. So if you remember with the put and also with the read one product, we found just the product itself with product.find, and then this sort of anonymous arrow function here. We find the product itself, but with find index, we now want to find the index of the product. So if we have 4, the first one will be the zeroest one, and then the second one will be the first one. It's zero-based indexing. So we find the index, and if that index is in fact like a true index, like starting with 0 and then upwards, so if it's not -1, essentially, we continue. If it is -1, which basically means we couldn't find that index, we send a 404. But if that isn't the case, we splice the products by the index, which basically means just remove that one index out of the array. So if that's all good, we send a status 204. That means, yep, content deleted successfully, all good. And then we send an empty response back, okay? So let's test that with a new delete.shell script. All right, here we go. So delete, let's write it all, quit, and then say shell test delete.shell. Okay, so we send an empty response back, so that's why we don't see anything. So let's go back here. Currently we have 3 products, and now we have 2 because we deleted one. Okay, we deleted the cardboard cutout from Josh Bentley. Too bad. Okay, so that was that. Very cool. Let me quickly skim through my notes, and while I do that, feel free to put any thoughts, feedback, questions, anything along those lines in the chat. Yep. All right, cool. So I think I covered all of the things that I wanted to cover so far. That's good. And now I already mentioned that the index.js has become quite complex already, right? It's already 107 lines, and we have basically just created CRUD capabilities. Again, with the Cloud Application Programming Model, that would be like 5 lines, but it is what it is. We're here to learn, right? We're building this thing from scratch. So let's work on simplifying our index.js a little bit, because also in a full-fledged like productive application, you don't want all your code to live in one single file. That's terrible practice, especially if there's multiple developers working on this thing, because you will get in each other's way all the time. So let's now work on separating things out a little bit more. Okay, so I will cut out this products array here and move it into a new file, which I'll call data.js. Okay, and then I will say that we export this const. So we export the products, and then we can go back into our index.js, and there we can say import products, not from products.js, but from data.js. So Copilot was navigating me in the wrong direction here. It's not called products.js, but data.js. Okay, so let's test that real quick, and it still works. So we get the data. And by the way, what you just saw, we had 2 products before, and now we have 3 again, because the server restarted, right? And it's pulling in the data again. So it's always like restoring its original state when it restarts, because we don't have actual persistence here, right? We are just mocking a database, essentially, you could say, because we are just grabbing data from a JavaScript object, and as long as that server is running, we can manipulate that object, but if we kill the server, we lose all of the modifications, right? So we haven't actually implemented persistence here. We sort of mocked it. I guess you could say in a 3-tier architecture, which we usually have, like with a client on top, then with a service layer, that sort of the logic layer, and then the persistence at the bottom. We have only implemented the second layer, I guess you could say. And we'll probably get into the 3-tier architecture when we talk about CAP, because it's a very prominent mechanism there, as well as in the overall SAP space, I guess you could say. That's where R3 got its name from. All right, so cool. So we are now down to 87 lines. Okay, that's a start. Okay, so let's now also move our error methods into another file. I'll create a new file called error. Error is a weird word, isn't it? Error, especially for someone who's not native. Error. Okay. Errors.js, and so we do have the send 404 thingy, send404, and that one actually already contained the export statement. I didn't mean to do that. That was probably some copy and pasta issue. Because obviously I tried these things out before the session. Okay, so next one would be the send400. Let's go back into the, let's search for send, oh, well, that doesn't work. All right, let's run through it manually. Do we have any other error thingies here? No, I don't think so. Okay, so now we have the error codes in the separate file, so we now have to import them. So we have the send404 and the send400 that we want to grab from the, yeah, and that's actually correct. Thank you, Copilot. All right, so let's test it again. And obviously to test that, we'll have to produce an error. So that works. Let's now modify the ID to something that doesn't exist. Okay, and we get the correct error message. That's good. All right, cool. So we made it to 78 lines. That's good. And what we can also do is we can move this thingy right here, which is our method that checks for the product and checks whether it is valid or not. Let's move that into a separate helpers.js, right? These are sort of our anonymous, not anonymous, but our detached, helpers that don't include the actual application logic. They're just, sort of, helpers on the side that make sure our code, works as expected, but it's not the actual logic itself that we're trying to implement. We're trying to, keep the index.js only to the, CRUD things itself, like defining the overall endpoints and things like that. So we'll move this method out. So we export it. I'm not sure if you saw, but I put the export statement in front. And now we can go in here and also say import is valid product, not from validations.js, but from helpers.js. Okay, all good. Let's run some tests again, like running tests. And with running tests, I mean doing manual tests, which is not ideal, of course. But we'll maybe get into testing, like proper testing as well. Okay, so let's also maybe do a post, because I know that with a post endpoint and with a method that we execute there, we do check for the valid product. So yeah, and that still works. So let's go back in here, and we do have 4 items. Okay, so let's see. Kind of progress have we made? Okay, we reduced it to 67 lines. Okay, we almost cut it in half. That's good. Okay, so that was the Node.js server with full CRUD capabilities. And as I mentioned before, there's frameworks out there, also in the SAP space, that abstract a lot of that work away from you, which obviously is a big help. But we're here to practice. We're here to get into the, the details of how a Node.js server in that case works. So I hope that was successful. Next week, we will continue with building out our front-end code. So a front-end for our fictitious web shop, you will never be able to order something, but at least we practiced, okay? So thanks everyone for watching. As always, put your thoughts, feedback, anything in the chat and in the comments. And I'm very much looking forward to seeing you next week. So thanks everyone. Bye.